Hello everyone, my name is Manshankar Reddy Kambam. So I'm here to present my paper Kafka, a distributed messaging system for log process. So Kafka is a framework and it's an open source streaming platform. It was first developed at LinkedIn by Jake Knapp, Neha, and Naghead and Juan Rao. So they all co-developed at the time around 2010, and it is released in 2011. So in 2013, Apache acquired Kafka, like they took the rights. So in 2013, it became Apache Kafka. So the main design before Apache took off. So it is first designed to facilitate active tracking and collect application metrics and logs at LinkedIn. So the main, what we can say, five tasks the Kafka is very good at. So it is queuing, metrics, log, database replication, and tracking data. So and also Kafka is mainly used at what we can say at places where we need high throughput, a high amount of data will be transferred, and uh, basically uh, where it has more data to store, more data to analyze. So Kafka is the system of choice for reliable collection, transmission, and delivery of any events. So okay, so coming to it's what we can say, it's a unique feature. It is unlike previous systems like IBM RabbitMQ and Apache Spark. It is designed on its own architecture. Unlike them, they it is designed on its own architecture, and it manages real-time data feeds with low latency and high throughput platform. And we can say the alternatives or competitors of Kafka is Apache Spark, RabbitMQ, ActiveMQ, Amazon Kinsys, Red Hat AMQ. So these all are some alternatives and direct travel for the Kafka. So the main point here is that Kafka is one of the reliable thing. Even though the competitors they have more features, more uh, all the things to do, it is more reliable. And when it comes to dealing with high amount of data, then it has to be Kafka. So it is one of the growing application. It is one of the fastest growing. So it is projected to grow from 1.6 billion in 2019. So the survey I'm here taking from 2019. So in 2019 it is estimated at 1.6 billion. And they estimated around 5.3 billion by 2025. So it's almost we can say 3 to 4 times the market. So the functionality of Kafka is it uses sequential disk in input output. So it boosts performance, making it sustainable option for implementing queues. It can achieve high throughput, as I said before, with limited resource necessity for big data use cases. So and also it is written in Java and Scale. The main reason, because the name Kafka come from its Franz Kafka. So the main person, Jaya, who while developing it, he thought it he thought of putting the name of the author. So it's Franz Kafka. So he took the name of he took name from them. He took name from him, and he he did like that. So the direct rival I can say is Rabbit MQ. It is developed by IBM. So as I told you before, IBM MQ has more features than Kafka, but Kafka is best suited to large data from words such as lambda and everything. So the key design principle of Kafka is its consumer itineraries. So pull model, even if we can say very big companies like Netflix, even the companies like IBM, Amazon, who has the own product of the own product which will replace Kafka, they still use Kafka. So even they still do the Kafka. And when it is like a very it is like what we can say, we can't unavoidable type of thing. So the efficient storage through offsets, page caching, time-based SLA for retention, all these key designs are the one of the reason for Kafka success. So it and so from now on, my friend Revan Mutyam, he's gonna take over the presentation, and he will explain everything.
Hi, from here I'm going to explain about the evaluation of the Kafka. In order to get the evaluation of the Kafka, we need to compare both the things like producer and the computer so that we can easily know how the Kafka is very important to us and in our daily life. If you compare in the graph wise, if we compare if with tools like ActiveMQ and the RabbitMQ, we can see that Kafka has a higher message per seconds, like it can handle more than 22,000 messages per second. But whereas when we compare to the ActiveMQ and the RabbitMQ, it only has a 144 bits overhead in active MQ. So we can, from this we can know the performance of the Kafka has a higher frequency than the active MQ and the rabbit MQ. And and the Kafka can be, it is, we can say that it is easily more than 4 times higher than the tools like HMQ and the Rabbit MQ, while considering into the log aggregators and the way from further and from the various messaging systems. And Kafka has a critique, and it is divided into three parts in our paper. So will consider as a replication, acknowledgement, and the processing capabilities. So if we consider in the very first step replication, it is same like a customer service. Whenever we're sending a message, if we get delay or if we get an error while sending a message, the replication will take care about all the messages from which we are sending from one client or one client to other client, or one customer to the client. So it is easily manageable, like it will automatically divide the solutions in some kind of parts. Like if the message has these kind of problems, it will goes into another section, and if the message is facing with some other problems, it goes into the other section. So in such a way it will be very easily to solve the issue when we are facing in the face facing like trouble in the sending the messages. So it almost the data among it divides device, and it will be get solution based upon the availability and the durability, in a very short span of time. And this is about the replication. And coming to the acknowledgement, and acknowledgement is very important because the customer has to know whether the message is delivered. He has to know that, he has to have some idea that whether the message is delivered to the uh, client or not. So if he wants to know that he is correct, that he has sent the message, he will be returning it a back acknowledgement. Like if he sends a message to the client, if the client has a solution, a particular solution for the problem, he will be sent back the acknowledgement with the answer to the customer so that he can easily solve. But if the client has no idea about the problem, he will be connecting to the any other services or any other supervisors like that. So the supervisor will be again send back acknowledgement to the client, and the client sends the same message to the consumer, so that in such a way it will guarantee message to deliver to consumer through acknowledgement. So he will be knowing what's happening in this process. And apart from this, it has a processing capabilities like not only solving the problem which is facing right now, but also he has, the Kafka has a capability in providing the many other features at the same time, like having a very proper connection between the customer and the client, and having a higher message delivery rate to the client to client and the web browser. This will be all taking care in the processing capabilities, and this is all be happening in the critic section. And in the next section, there is conclusion. Like like the money said, it has a very Kafka has a very important future in delivering the messages. So Kafka, well, the currently, if you consider Amazon, Amazon and the Google, the Amazon has Amazon managed streaming, that it also uses Kafka, and the Google like Confluent Cloud, it also uses the Kafka for the message delivery, because more than 33,000, like more than 34,000 companies will be using Kafka, like FireEye and Rushware. So that while using the Kafka, it also has a many solutions for the different kind of issues, like more than, if you consider in our country like USA, we got highest percentage, like we got 57% of users are in USA. So this is the best example, like Kafka is very actively growing right now in the present situation. And if you compare a real-time example, like Amazon, it can handle any kind of situation in delivering the products or in delivering the messages to the customers. And the final, the technical question is that from our paper, if you consider the performance in boosting performance of the Kafka, it is all run in the processing system like a message streaming queue. But is it possible to do the same thing with using the database such as Hive? Is it possible to do the same process in the future by using any database? That's the first question we have. And the second question is about the IoT device, like Internet of Things. Internet of Things, the main thing is it does not have any acknowledgement in its architecture, so that we are unable to hold the data loss. It always has a data loss. The data loss is more in IoT devices. So when we use Kafka, there is a possibility of heavy data loss. It will be a very huge risk in many cases. So by using Kafka, is it possible to do the same thing in the IoT devices? Thank you.
Okay, so uh, This is our paper review presentation. So my friend Revant, he covered the technical part of the paper, and I covered the introduction. So thank you.